Here at Roads and Maritime Services, we take our environmental responsibility seriously. My expectation is that project teams from both RMS and our partners in design and construction must be proactive in planning for suitable controls for changing conditions. All site staff should be aware of their responsibilities and should identify issues and act quickly to rectify them. Site teams need to understand the process for preparing construction sites for imminent rainfall events and the requirements for maintaining site controls. Erosion and sedimentation control is a key aspect of RMS commitment to minimise environmental harm. This video has been made to assist you to do this well. Your efforts in meeting our environmental obligations are really appreciated.
Hi and welcome to Erosion and Sediment Control Principles for Road Construction. I'm Peter Cahoon and joining me is Chris Blake, Senior Environmental Specialist, Land Management with Roads and Maritime Services. Now Chris, I know that no two road construction sites are the same, but take us through a typical catchment where road construction project might take place from top to bottom. Now let's use some animation to help us. What are the key principles?
Well, the first thing we need to do is we actually need to minimise the amount of water that we're actually dealing with on the construction site.
Okay, it makes sense. So how do we do that?
Okay, well what we need to do is we need to divert clean upstream water through or around the site without it coming in contact with our construction area. We call these clean water or off-site water drains.
So we've got the clean water safely through or around the site. Chris, what is the next big thing we need to think about?
Well, the actively worked areas of our site are prone to erosion and they have exposed soils, which is an erosion risk. We need to prevent as much erosion from these areas as we can.
Okay. And shortly we'll have a look at a range of erosion controls that we can use on site. I assume then, Chris, that we must also have another set of drainage for on-site water.
Yeah, that's right. So what we've got is what we call a series of dirty water drains, and that'll carry the water that falls directly on the construction site.
But I assume this dirty water, Chris, just can't be conveyed off-site.
Yeah, that's right. Despite our erosion controls, inevitably some sediment will be picked up and the dirty water drains convey this water and sediment to the sediment controls to treat that water prior to discharge from the site. At this point, the treated site water is discharged into the natural environment.
Okay. So we've managed water through our site. We've put in place erosion controls. We've put in place sediment controls. Are there any other principles we need to consider at this point?
There are a couple of key principles to guide site management. These include responding to changes in site conditions, maintenance of controls and preparation for rainfall, staging construction and providing progressive stabilisation throughout that construction process, and careful management of dewatering after rain events.
Okay, so now let's have a look at the details of these principles on site. We're around on site here, joined again by Chris Blake, and we've looked at the basic techniques of controlling water. Let's now look at them in more detail. That is minimising erosion and controlling sediment. We're at an actual water course, which is joining the site. Now, Chris, what are the basic goals here?
In simple terms, we have what we call upstream or upslope diversion, which will prevent clean water from coming onto the construction site.
Yeah, because if it runs across the construction site, it'll become dirty or contaminated.
Yeah, and it can greatly increase the volume of dirty water on site that we have to deal with. It can erode the site and it causes downstream pollution.
You end up with an eroded site and dirty water leaving the site.
That's right. Depending on the location and site conditions, we can choose to either divert the runoff through the construction site or around the construction site. What we've done here is we've created a concrete bund which will take the stormwater from the road and lead it into our cross drainage controls on the construction site. Then it can safely transfer across the site without picking up any sediment or eroding any material.
So Chris, what can we see here?
What you can see here, Pete, is a temporary drainage structure which is taking clean water around the construction site, which is over here. In that construction site, we're getting our permanent drainage culverts in place. And what's going to happen here is once we've got that permanent drainage in place, this temporary drain will be rehabilitated and revegetated and the flow put through that permanent drainage path.
Okay, now are there any other advantages?
Yes, there are, Pete, so let's go and have a look. So looking at this site from the other side now, Pete, what we can see in here is that culvert construction. We're actually dropping those culverts in there today as part of that permanent drainage. Over the back here we can see that clean water drain that we were talking about before. And as you can see, we had that water flowing through the clean water drain, and you can imagine the high flow events that go through there. So that water's not being channeled through the construction site. So those additional benefits are really around constructability, not getting delays in site, and when it's wet, getting back into those sites quicker.
And this permanent culvert is exactly where the natural water flow was.
That's right.
Yeah, so the temporary water course goes in, a nice dry site to put the new culverts in. Workers can access the site along with their machinery, less delays. Now we've talked about temporary cross-site drainage which diverts water away from its final course, which we can see here. Chris, what's the reasons for permanent cross-site drainage?
Yeah, sure, Pete. What we can see in this location here is obviously our temporary drainage that we've talked about flowing through there. That water is not impacting this construction site you can see here. And what we've got in there is we've got culverts being installed for permanent cross drainage. Now what we want to do in the principle is really getting that permanent drainage in as early as possible. That means we're going to be able to get that clean water from above the site through the construction site as it continues. What we'll see here over time is now those culverts are almost finished. There'll be a series of fill put above that, and then the road pavement will go on top.
So it's get the drains in and then complete the road.
That's right.
So we've isolated the upstream water around or through the site and isolated the construction zones. So we need to protect those exposed areas of the site with erosion controls.
Yeah, we've got a number of different techniques. We've got natural techniques. We can retain vegetation where we can. We can also use mulch and other natural controls. There's a series of products we can also use, like geotextile fabrics, plastics, etc. And what we're really trying to do is actually protect that exposed soil from that erosion process.
Is it fair to say you want to keep the natural vegetation in place as long as you possibly can?
Absolutely, Pete. So what we can see behind us is a good example. We're actually constructing a bridge over here. What the bridge will do is we'll actually concentrate high energy flood events through this channel adjacent to the bridge. So we need to put rock armour protection around that bridge. What the team here are doing is they're actually retaining that vegetation for as long as possible. And what they'll do is, on a daily basis, remove vegetation and then put that rock armouring in place, so we're not going to have an erosion risk.
Okay, so let's take a closer look at some of those erosion control techniques. So, starting with geotextile fabrics, which we have a great example of here. Now, Chris, I imagine you have to tie them down so they don't get washed or blown away.
Yeah, absolutely, Pete. So what we want to do is we want to make sure that water doesn't get under the geotextile fabric, which will cause erosion underneath it and make that control essentially useless. So starting from the top, what we want to do is we want to make sure we properly anchor that control in place by digging it in. Geotextile is held in place with large anchors, like this one. Yep. And as you can see, as it comes down the slope, the geotextile is lapped over the next one below it, so the water can flow over that without impacting the control.
Now, there are less obtrusive ways of doing it, and that's using sprays that bind the soil. Let's take a look at that. Chris, soil binders, what are they?
Pete, soil binders are effectively a glue. They're used over large areas as a form of temporary stabilisation.
Right, now where would you use them?
Use them on just about any exposed area on a construction site, Pete. They could be useful on batters like this one behind us here. They're also useful on stockpile sites. May also be useful on exposed area of the construction site that's not going to be actively worked for a period of time.
Okay, so if the site's shut down over holidays or Christmas?
Yeah, they're really useful for protection over those shutdown periods for exposed areas. Designed to be used for sheet flow. Yeah. They won't handle concentrated flows.
Now, how do you apply them?
Well, as a glue, they're generally mixed into water and generally sprayed on either with a water cart or some other spray technique.
Now, we've talked about low velocity sheet flows, but what if the water's more concentrated running through your site? That could cause some real damage.
Absolutely, Pete. So what you can see here is a concentrated flow drain and a couple of different techniques to actually make sure that doesn't erode. Up the top here we've got geofabric and little check dams, and as we go further down that slope there's jute meshing there to protect that soil from erosion from that concentrated flow.
Now, we've been talking about erosion controls, and to my eye, Chris, we're on a very steep cut piece of what will be a future section of road. I'd imagine there's potentially going to be a lot of erosion here during construction. How are you going to handle that?
Yeah, absolutely, Pete. So these sites, we often have large cuts, obviously to level that land so we can actually put an effective road on. And these are really high risk sites for us. How we're managing it is we've actually got sediment basins here that run along the side at the base of this actual cut. So that's our end-of-line control. But as you can see, it's really actively worked. We've got trucks running up and down there all the time. So what we need to do is actually have a responsive measure here, and we need to actually put in a responsive techniques like cut-off drains, which will get that dirty water actually to the controls on the side.
So we're talking about cut-off drains which carry concentrated or dirty water across the site. But in a downpour, won't they cause erosion in themselves across the site?
No, they're actually essentially erosion control, Pete. So what we'll do on a major slope like this is we'll set them in at a regular interval, maybe about a 20-metre interval. And what that's going to do, it's actually going to reduce the slope length. The water can act on that exposed soil, so we're going to get less total erosion. The cut-off drains will take that dirty water and transfer it to our major controls downstream.
Well, Chris, here's an example of a temporary cut drain.
Yeah, that's right, Pete. So as we said before, we'll cut these drains in as a temporary measure, particularly when there's rainfall imminent or we're going to have a site shut down. Generally on slopes they'll be cut in on the contour. This one's designed to take the water from this area of the site into a SED basin.
Right, so we've talked about erosion control, but I believe there are techniques that are relevant to both erosion and sediment control.
That's right, Pete. So a couple of examples of those include check dams and also the management of our entry and exit points from our construction site.
Now, check dams. You mentioned these before. What are they?
Well, Pete, check dams are literally small dams and they're set in perpendicular to the flow direction in a channel. And the idea of these is to actually slow down the water flow as the water moves down that drain, and also to provide some area for settling of suspended solids behind that as the water pools behind the control.
Right, now it sounds simple enough. How are they actually constructed?
Well, this one here is constructed of gravel bags. Generally, the check dams are constructed of gravel or sandbags or rock. Could also be geofabric wrapped rock. But a couple of important design considerations for them that you can see here. First thing, we want to make sure that there's a drop-down structure in the middle of the dam, so that'll allow the water to flow through, and to make sure that we've got the outside of the dam highly elevated above that drop-down. So that means that water's not going to flow around that dam and erode around the side.
So installation is paramount. What about the entry and exit points to minimise erosion and capture sediment? Let's take a look at that. So when we say entry and exit points, we actually mean coming in and out of the site, like here.
Yeah, that's right, Pete. So the entry and exit points for our sites can be another high-risk area. They can erode themselves, but also we've got a lot of truck movements coming in and out of that site. And mud attached to the tyres of those trucks when they leave the site can actually get tracked a fair way up the road. It can be a really big visual impact for us and lead to a pretty bad perception of the site.
Yeah, fair enough. Now, how would we deal with that problem?
Well, there's a number of different methods to deal with it. Firstly, we want to stabilise those entry and exit points. So what you can see here is this, on this gravel patch here, that'll actually stabilise that entry and exit point. But what we want to do is probably put a layer of something like geotextile fabric underneath, and that'll stop that gravel from soaking down into the mud.
Now, this looks like some sort of cattle grid.
Yeah, it does, Pete, but it's actually a designed shaker grid. You'll see that it's got the pointy tops rather than just the standard flat tops that a cattle grid would have. And that helps to actually further agitate the truck or the tyres as it goes across and remove more mud. But even using these controls mightn't be effective in really wet periods, and we may still get that mud tracking out on the road. So often we'll have to revert to a street sweeper to actually keep the road clean.
Okay, we've done everything we can to minimise erosion and capture some sediment on the way, but on a big site, invariably there are going to be some conditions that we haven't catered for. What controls can we use for dedicated sediment control?
We've got a pretty wide range of sediment controls we can use across our sites, Pete. And what our site teams will do, they'll employ a range of techniques so they get the right control for the right location, rather than just relying on one sole control.
So with a suite of controls, it's reassuring. You don't have to rely on just one. I'm looking here at a little garden variety fence. What are we looking at?
What you're looking at here, Pete, is a sediment fence, and you can see it capturing sediment on the site.
Okay, so I'm just turning up and rolling this stuff out. Any other considerations?
There are some serious design considerations or installation considerations for these controls, Pete. So essentially what we want to do is we want to put them out along the contour, and they're designed to take sheet flows, not concentrated flows. The other thing you can see here is they have to be staked at regular intervals. And what's really important for the said fence is it actually is properly dug in, so the bottom of it doesn't blow out with the rainfall or with the runoff and let that dirt go straight into the creek.
So even for the little said fence, there are design considerations. So Chris, tell me, when would something like this be installed?
So this would be one of the very first things installed on the site, Pete. Done before we clear any of this area. so we don't have an uncontrolled impact. So many of our road construction projects involve the clearing and mulching of vegetation. What we find is we can use the mulch as an effective control, both for sedimentation and also for cover protection for erosion.
That's what we can see here.
That's right, Pete. This is a mulch perimeter bund, which will provide protection for water running off the site. This one is covered with bird netting to give it some added protection. And you can see the sediment that's been captured at the base of the bund there.
It's like a little mulch dam following the contour, yeah?
That's right.
Seems pretty simple. What other considerations are there with using mulch?
One of the key considerations is they're designed to be used for sheet flow. They won't handle concentrated flows running through them. Also with the mulch, we've potentially got a problem with generation of tannins from that mulch. Now tannins is just a naturally occurring compound which makes the water dark, similar to tea.
Right.
So what we want to do is we don't want to over-apply mulch on our site, so we may get that problem. We also want to avoid using mulch from high tannin generating vegetation.
Well, the use of mulch is a simple, economic, natural way of controlling sediment. Now let's have a look at one of the really effective ways. Let's have a look at the big guns of sediment control, and Chris, they're sediment basins.
Yes, Pete. Sediment basins are our most effective way to control large volumes of sediment-laden runoff on the construction site. Sediment basins, or sumps, on smaller sites are essentially holding reservoirs, which will allow the water to sit and allow the sediment to settle out before the water is discharged to the receiving environment.
Question from left field though, are they static? I mean, do you just build them and set and forget?
No, they're designed to a certain capacity, so once they're full after a rainfall event, they need to be pretty quickly cleaned out to maintain that capacity for the next runoff event.
So sediment basins, an important piece of armoury in containing and controlling water and capturing sediment. And here's a great example, Chris. It's in early before the major road construction starts.
Yeah, that's right, Pete. So as we said before, it's really important for us that the controls get in there early. As you can see here, they haven't started clearing that hillside yet, and as soon as they do, we know we're going to get erosion off there. So it's really a matter of the whole project team working together to work out a way to get these controls in place before they're getting into the major construction work.
At the planning stage.
That's right.
Well, behind us is another great example of a sediment basin designed to capture and contain the water. But what happens in a rare big storm event, Chris?
So as we said before, the basins will capture a certain design storm event. But what we've got to think about is we are going to get those really big stormwater events, and they can really rip through the site and damage our controls. And that's where we get real impact. So what you can see here is a really good example of a fixed outlet for a basin, and that outlet has been well protected with a rock. It's not going to wash away in those really big storm events.
So we've looked at the physical controls used to minimise erosion and capture sediment, but Chris, I'd imagine keeping control of the site would help as well.
Absolutely. So it's about anticipating upcoming activities and keeping on top of proactive planning.
Right. Proactive planning and monitoring, I imagine those two things are linked.
In any of our construction projects, conditions in any one catchment is going to change drastically over the course of the project. So many of those changes can be anticipated and some can't be as well.
This is a perfect example here because we've got a lot of major work and a lot of changes happening in this section of the road.
What you can see here is what we've got is we're constructing one carriageway, building a wall to construct that carriageway there. At some point, we're obviously going to have to shift the traffic from the existing highway onto that carriageway so we can then finish the project on the other side.
Yeah.
So we're going to have major changes to drainage through the course of the project. If our controls aren't in place to manage those changes, we're going to be in trouble.
So proactive planning, Chris, and keeping on your toes with the changing site conditions will minimise erosion and the sediment. Now, Chris, we've been monitoring all of these control points to make sure we stay on top of site conditions, but I imagine maintaining the control points is important.
Absolutely, Pete. So our controls can get damaged over time, particularly with high rainfall events or high velocity flows running through the site. And over time, a lot of the controls will actually fill with sediment. But it's not just the controls with filling with sediment that might have an impact. Damaged controls can actually make the situation worse. So if we've got high flow rainfall or runoff running through a hole in a control or a gap in a control, it can actually create erosion itself and continually scour the site.
Yeah, sounds pretty ugly. So it's important to stay on top of those maintenance issues of those control points. What are we looking at here?
Okay, Pete, well this is a small check dam, and as you can see it's in a series of small check dams here. Two things I'd like to point out here. Firstly, just have a look at how much sediment that's been captured. They actually do a significant job in terms of preventing this stuff going off site. Second thing is, obviously after the last rainfall event, it's still full of sediment, so it's certainly not going to do the same job next time. So what we need to do is get in and dig that out, and then we've got the control ready to go for the next rainfall event.
Yeah, so it's not only monitoring, it's maintaining all those control points.
Absolutely.
So we've seen the benefits of construction staging, but to reduce the overall impact of erosion, it's important to stabilise each section of the construction zones as we go, like this beautiful battery here, Chris.
Yeah, progressive stabilisation is really important to reduce the overall erosion risk of the project. So what we're doing effectively is isolating areas of the site that are completed, so we can apply surface covers like vegetation and mulch.
Minimising erosion and controlling that sediment. Now, Chris, a little bird told me that dewatering is one of the biggest environmental risks that the RMS faces. Why is it such a big risk and how do we get around it?
Sure, Pete. Well, dewatering is essentially removal of ponded water either from sedimentation basins or from other areas of the construction site. Why it's such a big risk is it's a controlled activity, so it's obviously follows on from a storm event and it uses techniques such as pumps. And the main danger there is that your pump may drop and fall into the sediment and pump that sediment into the receiving environment.
So, Chris, no unattended pumps spewing sludge into the environment?
No, Pete. It's our expectation that all dewatering activities on our construction sites will be done in accordance with a site-specific work method statement. And that work method statement should detail several key things. Firstly, that there's training of staff that are going to undertake the activity, that the information on that training or the key elements of that is included in inductions onto the site. The work method statement should also have an approval process to commence each of those dewatering activities on the site.
So, Chris, I can see there's a lot of good erosion sediment controls there, good examples on RMS construction sites. I can see that a lot of people need to be on their toes to achieve this, but how are these things practically applied day to day on a construction site?
Well, at RMS, we consistently refer to engagement as the key thing in getting it right. By engagement, we mean the construction and environment people in each team continually working together to ensure controls are effective. This is not just about getting an environmental outcome. It's about construction efficiency and project success.
And what we've talked a lot about out there is the importance of forward planning to get these controls in place as early as possible.
Yes, and forward planning and proactive response are important for success. We can't get the good results that you've seen unless people working on the site are clearly instructed on what they have to do.
So it sounds as though you need a good site management plan to me.
Yeah. Each construction site must have an overarching primary erosion sediment control plan. For detailed site team guidance, there must be a site-specific erosion sediment control plan for each catchment location. We call these progressive erosion sediment control plans. Progressive plans will generally be drawings that show the current conditions on the site and the controls that are required.
And I assume, Chris, you can update these plans as the site changes.
Yeah, and look, of course, the crew installing and maintaining the controls need to be trained in what they're expected to do.
So when we first started, Chris, I thought erosion and sediment control was pretty easy. But now I see a lot of work needs to be done to get the right controls in place at the right time and to continually maintain and upgrade the controls right through the construction of the job. This is a big challenge.
That's right, it is a big challenge. But as you've seen, it's a challenge that RMS and the contractors delivering our projects can meet.
Now, Chris, if people are interested in more information or advice about erosion and sediment control on RMS construction sites, where do they go?
What we've got is what we commonly call the Blue Book. This is essentially the New South Wales Bible for erosion and sediment control. The Blue Book is a very comprehensive overarching document that covers every aspect of erosion and sediment control. There's generic information in Volume 1, and there's also road-specific information which is contained in Volume 2D. Also, RMS have an erosion sediment management procedure that is used to identify high-risk sites in the planning phase. We also have a number of RMS documents that focus on the likes of temporary cross drainage, stockpile management, dewatering and water quality monitoring. Most of our key information and guidance documents are available on the RMS internet and intranet sites. We also have environment officers in each region around the state who can assist and also provide contact for relevant specialist consultants. If in any doubt about any aspect of erosion and sediment control, it's better to ask for help. It's much better than getting it wrong.
Well, Chris, I have to say erosion and sediment control has been an eye-opener for me. Most of it might seem like common sense, but like everything, the devil is in the detail. Keep vigilant and keep those waters clean.